Hello, I'm Azin Semsar from UMBC presenting our paper Quality of and Attention to Instructions in Telementoring. Increased distributed workforce has resulted in a great focus in both industry and research to best support remote collaboration through tele-instructional tools. These tools incorporate three fundamental functionalities: an audio connection, a video connection of the workspace, and some form of pointer to annotate on the shared video. However, still, studies to this point have found that in most cases, a co-located condition supersedes a distributed condition in terms of performance and task outcome. One explanation is that trainers in a co-located condition provide more accurate instructions. Another explanation is that local workers extensively attend to pointing or visual instructions as the primary source of information and ignores any simultaneous verbal instructions, thus result in misunderstandings and mistakes. For that, we conducted a systematic comparison of instruction provision and perception parameters in distributed and co-located collaborations. Our study domain is surgical telementoring, where an experienced surgeon remotely shares knowledge to a less experienced local surgeon in performing a laparoscopic surgery task. In laparoscopic surgery, a long fiber optic camera provides the surgeon with a view of the operative field on a display. This view is lively transferred to remote experts to observe and advise accordingly. So what did we do is that we conducted a within-subject randomized experiment with two conditions, co-located and distributed. A total of 12 surgical trainees and one attending surgeon as the trainer were recruited. We collected audio, video, and laparoscopic recordings. Our measures included performance through questionnaires and task completion time, quality of instruction, again through questionnaires, and also the number of instructions and pointing supplemented instructions, and also attention through eye tracking data such as fixation count and fixation duration. And we performed statistical analysis of linear mixed models to compare measures between the two conditions. What we found is that we identified no statistical difference in performance between the two conditions. Surprisingly, the quality of instruction was perceived significantly higher in distributed conditions. Specifically, trainees found the quality of instruction pertaining to anatomical or object identification higher in the distributed condition. Our analysis of the instruction provision showed that obtained higher quality of instruction in distributed mentoring was not due to the quantity of instructions provided, either visual or verbal, as these numbers were not statistically different between co-located and distributed conditions. In analysis of our eye tracking data, lower fixation rate and the longer fixation duration revealed that trainees took a more efficient visual search strategy in the distributed condition. Analysis of eye movement around the pointer revealed trainees have an overall greater attention to the pointer in the distributed condition, especially while anatomical identification instructions were provided. Our main finding was that in a distributed learning environment, trainees changed their behavior to attend more to the provided instructions, resulting in higher perceived quality of instruction. In fact, trainees are more cautious about the instructions and particularly pointing instructions in telementoring. This can be related to the media compensation theory that says people try to compensate for the limitations and unnaturalness of the media by changing their communication behavior. We suggest socio-technical implications for supporting telementoring based on our findings. First, the broader implication is to support the telementoring with greater information conveyed through the visual channel because the local workers are more cautious toward visual information. The pointer mostly facilitates the object identification phase. The socio-technical implication here is to train the trainers to maximize the use of pointer in object identification instructions. The procedural instructions such as orientation and hand placements or showing trajectories need to be better supported by training the trainer to use the drawing tool more effectively because the drawing tool is suggested to be proper for procedural instructions. Thank you.